Hey, and welcome back to Unit 9. It's time for our next installment of factors and factoring. So yesterday we talked about greatest common factors. Today we're going to factor by greatest common factors, whatever that means. So let's start with this little review. It tells us we need to distribute the 2x. Okay, we've done that before. So what we're going to do is we're going to take this 2x and we're going to distribute it to the 5 and to the x. Okay, so what is 2x times 5? Well, 2 times 5 is 10. X times nothing is just x. Okay, we're done with that one. Bring down the plus sign. Now we're going to do 2x times x. Well, 2 times nothing, okay, 2. And then x times x is x squared. All right, so we could write this in standard form, but we don't need to right now for the sake of this example. So what it tells us to do now is it gives us the same thing that we just did, that we just got, the 10x plus 2x squared, and it says, now can you undistribute that 2x? So they want us to undo what we just did. So if we undistribute, we're going to bring the parentheses back. We're going to pull out the 2x. So we're going to take the 2x and we're going to put it back out front. And then we're going to go term by term and we're going to ask, well, what did this one used to be? Well, before we multiplied it by 2x, it was 5. And then this one, before we multiplied it by 2x, was just x. So we can double check, go back, yeah, it was 5 plus x. And then if we didn't just do that problem, here's how we could double check to make sure that we undistributed correctly. We could multiply it back out. Well, 2x times 5 is indeed 10x, and 2x times x is indeed 2x squared. So yes, we undistributed correctly. So we pulled the number out and we have the right number inside the parentheses. So it turns out there is a fancier term. They didn't like the way undistribute sounds. They decided to call that factoring. So if you're going to undistribute a term, that's called factoring out a term. So one last purple example. This one tells us to factor out, that's undistribute, a 5. So I'm going to go ahead and pull a 5 out. All right, so I'm asking, what did it look like before someone distributed a 5 to both of these terms? So before this one got a 5, so basically we're dividing by 5. Well, 25 divided by 5 is 5. But this x cubed, nothing got affected there. That was still a plus sign. And then before this one got multiplied by 5, what was it? Well, that had to have been 4. I'm just dividing it by 5. Okay, so all I'm doing is I'm pulling the thing out and then I'm dividing each of these terms by that number. Now to double check, I could redistribute this 5, and sure enough, I get the original back. For example 1, please write it down, copy it, and try it on your own. So it told us to factor out a 6. So I know that I'm going to have a 6 pulled out front. And then I'm just asking, hey, before someone distributed a 6 to each of these terms, what did they look like beforehand? So each one, I'm just dividing by a 6. So what's 42 divided by 6? That's going to be 7. And then nothing happens with this x to the 4th. Bring down the minus. What's 24 divided by 6? Well, it's going to be 4. Nothing happens to this y. If I want to check that my answer is right, I can distribute this 6 back out. So indeed, 6 times 7x to the 4th is 42x to the 4th. Bring down my minus sign. And 6 times 4 is 24y. So yes, this is the original back. Okay, example 2. Now we're not factoring out a number, we're factoring out an x squared. So I know that I'm going to have an x squared pulled out front. I'm going to bring my parentheses back. Okay, so this one, 3x squared. So what was it before it got multiplied by the x squared? Well, it had to have just been a 3, right? Because 3 times x squared is 3x squared. Bring my plus sign down. And then this one is an x cubed. So before it got multiplied by x squared, what was it? So really what we're asking is, what is x cubed divided by x squared? Well, we know that that's just going to be 1x. So that's just 1x here, and you aren't going to write that to the power of 1 there. We don't need that. So let's double check this. Let's redistribute. Okay, so x squared times 3, yeah, that's 3x squared. Bring down the plus sign. And then x squared times x, yes, that is x cubed. So yes, I do get the original one back. Now it tells us to factor out the greatest common factor. So they don't tell us what to factor out. We need to figure that out ourselves. So I need to look at each of these terms, 14x squared and 16x, and figure out what is the greatest common factor between those. We did that yesterday, or last time we had class. So between 14 and 16, I could list out all my factors of both of those. 1, 2, etc. But I see that the biggest common factor is just going to be 2. I'm kind of thinking about it in my head. Okay, so it's going to be 2. And then looking at the x's, what's the biggest x that we have in common? Just one x, right? So looking at the exponents, I only have 1. So this is the number I'm going to pull out. This is the greatest common factor. So they could have also said, hey, factor out a 2x, but they wanted it to be more work for us. Okay, now we're going to go one by one, and we're going to divide by this 2x. So if I had 14x squared divided by 2x, well, what is that? It's going to be 7x. Bring down this minus sign here. And then I'm going to divide that 16x by 2x. 16x divided by 2x. Well, 16 divided by 2 is 8. X divided by x, I just don't have any x's left anymore. So let's check. Let's multiply it back out and see what we get. Yep, sure enough, when I multiply it back out, I get the original expression back. So good, that means that we factored it correctly. Alrighty, write down these steps here for how to factor out the greatest common factor. First, you need to find the greatest common factor, and then you need to factor it out, just like you would any other term. All right, so let's look at example 3, factor out the greatest common factor. So I'm going to look at each of these terms. I have 4x to the 5th and 12x cubed. I need to find the greatest common factor between those. So if I look at the 4 and the 12, well, the biggest factor they have in common is the 4 itself. And then I'm looking at the x to the 5th and the x cubed. What's the highest exponent they have in common? Well, it's going to be this 3 here. So it's going to be x cubed. Okay. Put in my parentheses back. And now I'm going to ask, what did it look like before I distributed this 4x cubed? I'm going to undistribute that 4x cubed. So really, I'm dividing each term. So I have 4x to the 5th, this first term, divided by this 4x cubed. Well, 4 divided by 4 is just 1, so I'm not even going to write that one. Then x to the 5th divided by x squared. I subtract the exponents, I get x squared. Bring down your minus sign. All right, so now I'm looking at my next term. I have 12x cubed. And I'm going to divide that by this, the 4x cubed. All right, well, 12 divided by 4, that's 3. And then x cubed divided by x cubed is just 1. It goes away, so I'm not going to write anything after that. It's just 3. So it looks like this is our answer. I'm going to multiply it back out to double check. All right, and so we got our original answer back, so it looks like we factored it out correctly. For example 4, pause the video and try these on your own. When you unpause it, I'm going to have the answers up here for you to check. So here are our answers. For the first one, 4w squared and 3w, the 4 and the 3 had nothing in common. There was only one w in common, so that's what we pulled out. So for each of these, it just went down by 1w. This one used to be w squared, now it's just 1w. This one used to have a w, but now it's gone. On this one, looking at our constants, 10, 20, and 5, well, we had a 5 in common in all of them. And then for our y's, the biggest exponent that we had was this one. It was just 1y. Be very careful with this n term. I know that a lot of us are probably going to mess up on that one. So when it's 5y and you're dividing by 5y, 5 divided by 5 is 1, y divided by y is 1. So you can't just leave it off. You do actually need to write a 1 there. And to double check it, multiply it back out. And sure enough, 5y times 1 gives us 5y. But if we didn't have that times 1 there, then that last term would just disappear. So yes, this matches what we originally had. So yes, we must have factored out correctly.